We're going to talk about how to write linear equations when we're given different sets of information here. So in this first one, first let's review what slope-intercept form looks like. We have y equals mx plus b, where m is the slope and b is the y-intercept. And let's go ahead and just remember what the slope formula is. So anytime we know 2 points, we know that the slope between any 2 points is y2 minus y1 divided by x2 minus x1. Because that's going to come in handy if we're trying to write equations in slope-intercept form. So, this first example here, we want to write an equation in slope-intercept form for the line that has a slope of -2 and passes through the point -4, 6. And we're actually going to do this 2 ways. The first way we can do this is, let's go to the point -4 and 6. 1, 2, 3, 4, 5. So that's this point. So in order to write the slope-intercept form, I need to know 2 things: the slope and the intercept. So I already know what the slope is. I know m equals -2. So I'm trying to fill in information here, right? And I already know that m is -2. And that tells me my rise over run, my change in y over change in x. So one way I could figure out what the y-intercept is to keep plotting points on this line until I hit the y-intercept. So since the slope is -2, that means I'm going to go down 2 and right 1, and every time I do that, I hit a point. So if I go down 2, right 1, I hit that point. I go down 2, right 1, I hit this point. Down 2, right 1, down 2, right 1. And I have my y-intercept. So from this, I can see that b equals -2. So that's one way we can do this. The other way is just going to be using algebraic equations. So we're given this point here, and we know -4 is an x, and 6 is a y. So in this equation, we know if x is -4, then y has to equal 6. So we're going to substitute, right? So we substitute 6 for y, and we substitute -4 for x, and we know that the slope is -2. And again, we're pretending we don't know what b is for a second. And I can solve this equation for b. So 6 equals -2 times -4 is 8, plus b, subtract 8, and we get -2 equals b. So either way, we got the same answer, right? So then our final slope-intercept form of the equation is we're going to leave x and y back in this equation, and we're going to fill in m and b. So y equals -2x minus 2. It's really helpful to be able to do both of these methods. The advantage to this one, the advantage to the algebraic one, is when you solve this algebraically, this one will always give you an exact answer. What did I do? There we go. So that method will always give an exact answer. And the one on the left, where we're counting, that one is prone to, I guess, estimating errors, which you'll see in a second. So example A here, write an equation in slope-intercept form for each graph. So example A, so in this one, we can actually almost see the y-intercept in the picture right up there. And just to double check, let's count down on these points. So let's find the slope. So we have 1, 2, 3, 4, 5, 6. So our change in y is negative 6. And our change in x is 2. So that means our slope is negative 6 over 2, which would be negative 3. So if I continue counting, so now I'll count up and to the left. If I go up 3, 1, 2, 3, and over 1, then I land on my y-intercept, right? So I get b equals 9. So the equation for this line is y equals negative 3x plus 9. Example B is definitely going to be one that we want to solve algebraically, and here's why. We can see right there the y-intercept is somewhere between 1 and 2, but we can't just eyeball it. If you try to eyeball it, you might say that the y-intercept is a half, and as you'll find out in a second, you would be wrong. So we can count the slope. So the slope, we go 2, 3, 4, 5, 6, 7, 8, 9, and up 1. So our slope is 1 over 9. And then, so y equals mx plus b. We know that m is 1 over 9. So to find what b is, we're going to take one of these points. And doesn't matter which point you take, you'll get the same answer either way. But I am going to take the one that has positive numbers, because those are going to be easier to deal with. So 5 is an x value, and 2 is a y value. Right? So I'm going to plug in those numbers for x and y. X and y. And I know that 1/9 is my slope. So now I have 2 equals 1 over 9 times 5 plus b. So 5 times 1 over 9 is 5 over 9. Notice we're not going to use decimals here, because decimals, when we have a denominator of a number like 9, decimals aren't going to be nice. So 2 equals 5 over 9 plus b. And then we're going to subtract 5 over 9 from both sides. And in order to subtract 2 minus 5 over 9, we need to find a common denominator. So I'll do that off to the side here. So 2, my common denominator is going to be 9, of course. So 2 over 1, I'm going to multiply by 9 over 9, and that's 18 over 9. So 18 over 9 minus 5 over 9 equals b, and 18 minus 5 is 13. So 13 over 9 equals b. So as I warned you earlier, if you had tried to guess and say that b was maybe 1.5 or 1 2/3, you would have been wrong, because 13 over 9 is neither of those things. So our final equation here is y equals 1 over 9x plus 13 over 9. So these two are perfect examples of why sometimes you can just use the eyeballing method and figure out exactly where the y-intercept is. But other times you really do need to solve algebraically, especially if you see slopes with a denominator of like 9 or 7, then it'll be really hard to just guess exactly where that y-intercept is. So on to the second page. So parallel and perpendicular lines. So parallel lines have equal slopes. So 3x minus 6 and 3x plus 2 both have a slope of 3, therefore the lines are parallel. perpendicular lines, and remember that means perpendicular lines intersect at a 90-degree angle, and parallel lines never intersect. So parallel lines have equal slopes, and perpendicular lines have slopes that are negative reciprocals. So remember, they have to be negative and reciprocal. So 3x minus 6 and negative a third x plus 2 are perpendicular, because negative a third and 3 over 1, we have one's negative, one positive, and then they're reciprocals of each other. So write the equation slope-intercept form for the line that satisfies. So we have passes through the point negative 4, 2, and is perpendicular to, or parallel to 1/2 x plus 5. So what's important here is just that the slope of my new line has to be a half. And it has to pass through the point negative 4, 2. So since we don't have a graph here, it's easier just to solve these algebraically. So if it passes through negative 4, 2, that means, so here's our slope-intercept form again. So mx plus b. We know that m is 1/2, and we know that when y is 2, then x is negative 4. So 1/2 times negative 4 plus b. And then we just solve this. So 2 equals half times negative 4 would be negative 2 plus b. And 2 on both sides. And we get 4 equals b. So our equation here, now substituting, since we know what b is and we know what m is, our equation is y equals 1/2 x plus 4. So our second example here, now we have passes through 3, 1 and perpendicular. So since this slope is negative 3, our new slope is going to be, so this is negative 3 over 1, so our new slope is going to be positive 1 over 3. So again, we substitute. So we start with mx plus b, and we know that when y is 1, 1/3, and x would be 3 plus b. So 3 times 1/3 is 1, and then we would subtract 1 from both sides, and we get 0 equals b. So our slope is 1/3, and our y-intercept is 0. So our equation could be 1/3 x plus 0. And since we just have a plus 0, most of the time this would just be written as y equals 1/3 x, since the plus 0 is inconsequential. So now we have a line that passes through 1, negative 1, and parallel to the line that passes through 4, 1 and 2, negative 3. So we have a bit more information here. So from these two points, I need to get the slope. And then I'll use this other point to find the equation of my new line. So let's call x1, y1. This one's x2, y2. So we have negative 3 minus 1. So the slope of our line is going to be negative 3 minus 1 over 2 minus 4, which is negative 4 over -2, which simplifies down to +2. So that's the slope both of this line and the line that we want. So parallel lines, those are same slope. And now we're going to use this point here. So our slope is 2. So -1 is our y value, equals 2 times 1 plus b. Remember, that's a y value and that's an x value. So -1 equals 2 plus b. Subtract 2 from both sides and we get -3 is equal to b. So our final equation is y equals, our slope was 2 and our y-intercept was -3. There. Finally, we have a line that passes through 4, 7 and perpendicular to the line that passes through 3, 6 and 3, 15. So perpendicular is going to be a negative reciprocal slope, right? But this one is a little bit of a trick question, because the line that passes through 3, 6 and 3, 15, so if you try to use the slope formula on this, you get 15 minus 6 over 3 minus 3, or 9 over 0. But dividing by 0 doesn't work. So what we have here, I'll draw a picture, is, so this is 3, 6, and then 3, 15 be somewhere up here. So what we have is a vertical line. And a vertical line has an undefined slope. The line perpendicular to a vertical line would be a horizontal line. So if this is vertical, right, then perpendicular is going to be a horizontal line. So we want it to pass through 4, 7. So let's say 4, 7 is right there. And that line would look like this. So a horizontal line that passes through a y value of 7 would just be y equals 7. So this has a slope of 0 because the vertical line has an undefined slope. Okay.